Well, the moderator of the next panel on virtual reality and space exploration, in my mind, could not have been more chosen more successfully. In the past 25 years, Jacki Morie developed techniques to make virtual reality environments more immersive and more emotionally compelling. After which she combined art and technological topics at Walt Disney feature animation, which she later expanded to the special effect industries at studios such as Rhythm and Hughes. Jacki also invented a scent collar to bring smell to immersive experiences. Well, personally, I think that's a double-edged sword. Yes, it does make the experience more real, so soaring over the Californian citrus groves at Disney and smelling the citrus while doing so is great. But I don't think I would want to really smell a battlefield, as some smells are better not included in the VR world. Be that as it may, Jacki Morie is a pioneer in virtual reality and as such is eminently suited to introduce the members of her panel to us. Jacki.
Thank you, Artemis.
Those are all yours.
Okay, we will do that. Everybody. Make sure we know who we are. Oops, you got yours? All right, everybody, welcome to this panel on virtual reality and space exploration, which is, of course, its kind of own exploration of space, but coupled with what we can do for the space exploration that's going to get us to Mars, I think you're going to be excited to see how many things are happening in this domain. So I'm going to quickly introduce our panelists. They are all stellar, and to really look up all of the things they've done, you should just Google them because it's amazing. But I want to get to where they are showing you the work that they are doing with virtual reality for NASA. So on my left is Larry Dungan. He's been with NASA since 1996 and has been the project manager and electrical designer on the Active Response Gravity Offload System, or ARGOS, project for the past 5 years. He has degrees in electrical engineering, and before joining the ARGOS team, he was the Environmental Health Systems Group lead for environmental monitoring of the Space Shuttle and the International Space Station. Dungan's been an electrical designer on numerous flight hardware projects in the area of laptop computers, power supplies, and photo-video hardware. So he'll be telling you about some of his work in a minute. Dave Lavery currently works at the NASA headquarters in Washington, D.C. as the program executive for solar systems exploration. He oversees and is heavily involved with the Mars exploration rovers. Dave's degrees are in computer science, and he is responsible for the executive oversight of the design and development of the next generation of the Mars exploration spacecraft and the advanced technologies to enable them, which includes projects such as the Mars Science Laboratory, the MAVEN project, the Mars Exploration Rovers, and also he is responsible for the Mars Advanced Technology Program that is creating new approaches to remote exploration by these robotic systems. Julian Reyes, next to Dave, has a history in entertainment and in developing interactive event technology, including very exciting experimental content with sonic and visual components. Currently, he is the lead VR producer for Fusion, an ABC Univision joint venture where he is leading Fusion's virtual reality team and producing even more exciting experimental content. Peggy Wu, last but not least, her background is in computer engineering, and her research interests involve supporting space exploration through VR, psychology, computer science, and human factors. Ms. Wu has been awarded several NASA research and cyber contracts, the most recent of which she'll talk about today, the Ansible project, which I am fortunate enough to be a partner on, so I don't have to talk about what I'm doing, because Peggy's going to talk about it. And that is to explore the use of virtual environments to provide psychological support for astronauts on these long-duration space missions. And I'm Jacki Morie, which is is it this one? Which one is the advance? And the reason I'm moderating this partly is because in 2010, NASA commissioned me to write a technical report on how VR could be used to mitigate some of the issues that would happen in these long-duration space missions. And that turned out to be 140 pages, which they cut down to 40, and then started looking at ways that VR could be used. But one thing I want to say is if you have some questions, you can tweet them to this hashtag, #GettingToMars, and I'll field those into the panel as they fit. What we're going to do now is I'm going to let Larry take over, and he's going to tell a little bit about some of the long history that NASA actually has with VR. I don't think we'd have VR today the way we do if NASA hadn't been so involved with it in the 1980s and 90s. So without further ado, Larry.
Thank you. So this here, my talk is primarily going to talk about hybrid reality at NASA. This front page picture is kind of a dream training or testing facility that we could have on the ground. And let's see if it will go. Oh, what? One of the things I want to bring forward is why do we want VR or hybrid reality? Part of it is, preparing for exploration. You've seen a lot of roadmap pictures today. And one of the things is, out of all of those roadmaps, you need relative analogs or environments for doing the development that's needed to move forward. And those are listed there. And also, the goals of hybrid reality is to take parts of virtual reality and interactions with the human and enhance that environment. As Jacki mentioned, there's kind of a long history at NASA with virtual reality. And starting about the mid-1980s, Ames Research Center and started designing virtual reality goggles. And the pictures in the top right are kind of two of the concepts, a little bit different than what we have today. Starting in 1991, the Virtual Reality Lab was started at NASA JSC, primarily to augment the training facilities for the crew members. And you can kind of see there's a list of missions there that they've supported. The big thing is in 2012, the first virtual reality training was conducted on board the ISS. And that's shown in the bottom left. And we don't quite have the virtual goggles up there yet, so it actually is a laptop with a hood that generates the virtual environment. So now getting into my part is the hybrid reality. On one side of the screen, you'll see a person in the lab. And actually, it jumped 2 slides. I'm sorry. I'm going to have to back up one. Me and the clicker are going to disagree today, it looks like. So this is one person is in our hybrid reality lab, and what you're seeing on the other side is what they're seeing in the virtual goggles. Hybrid reality is the combination of kind of the real world and the virtual world. If you notice, he's actually walking around, and in VR, he is seeing handrails on the International Space Station. When he reaches out, he is actually grabbing the handrails and physically holding on to them in the lab. It's kind of this combination of real world and virtual world. On the next video, you'll see how he's going to interact with the box. He's going to walk up and literally pick up a box that has the tracking in it and essentially place it. This could be used for doing crew training with cargo transfer bags, working with different experiments. But the idea of actually being able to move physical hardware and seeing it move in the virtual world is very powerful. One of the favorite views on the space station is out of the cupola. And this here is the cupola in the virtual reality. You can see the Earth model down below. It is moving in the correct speed that you would have from International Space Station. You can see the Soyuz capsule out of the side window. We brought a couple crew members over that had flown to station prior to the cupola, and they were pretty amazed at what the view was and kind of wished they could go back. Here, one of the other big things of hybrid reality is having the correct physics. If you notice in the picture, it took kind of some training manuals, and literally you're bumping them around. If the contact physics is all modeled, and KID is very realistic. We had another crew member who was commenting about the ability that, bumping things around and moving it was very close to what you would actually see. In this case, they're interacting with one of the flashlights, and also the shadow modeling is correct. Here in a second, you're going to see the light get kind of tossed down the ISS. You can see how the shattering and lighting effects work. We believe that having the physics and the lighting be very accurate enhances the realism of the environment that's being generated. Here's a case where we're using controllers and turning them into tools. In this case, he's going to use a magnetic tool to pick up a screw and then a screwdriver to install the screw. One of the next steps in the development is to actually shift to the physical tools, and that's something that's going on right now. Hopefully in the next few weeks, they'll have the actual tracking and models of the tools whether we can start moving away from the hand controllers. Imagine doing a EVA or an on-orbit repair in VR before you ever had to go forward and do it on the space station. Let's see. And can you start the video, please? This here is virtual reality from the Apollo 14 landing site. What it is they actually took the survey maps from Apollo 14. As you can see, you've got a crew member that has boarded the rover and they're looking around. In this case, you could actually be sitting in, say, a full motion-based chair using the actual steering or controls to move around. Here in a second, we're going to take a short tour of the Apollo 14 site. You can also do things where you're moving cameras, taking data samples, setting up instruments. We have, if you go out and look on the web, there's some video showing that. So the project that I'm responsible for also is the Active Response Gravity Offload System. We joke it's NASA's anti-gravity room. It's a large, scalable robotic system that we offload a portion of the person's weight, or an object's weight. And so what you're seeing in the video here is a spacesuit test in Martian gravity. And you see he's actually using EVA tools and shoveling regolith. This summer, we're going to be combining this hybrid reality work with ARGOS. So kind of concluding, imagine being on Mars in virtual reality, in Martian gravity on ARGOS, collecting regolith samples using actual EVA tools. That's our goal that we plan to make happen this summer.
That's awesome. And now, Dave Lavery.
Okay, actually, can we stop the video? Not quite yet, please. A little bit early. What I want to talk about just for a moment first, and we'll show the video, is one of the projects for which I'm responsible is the Mars Science Lab, MSL, with the Curiosity rover, which is active on Mars right now. And one of the things that we found in the course of going through and defining the operations system that is used every single day by the engineering and by the science team is that our ability to have the science team members and the rover drivers really understand the context in which the rover exists on the surface of Mars is a lot more error-prone than we ever thought it was. And the way traditionally that the science team members, we got 75 of the best planetary scientists in the world who gather together virtually via teleconference and video conference every single operational day to digest the information that was downloaded from the rover last night, take a look at it, try to understand it, and from that determine what they want to have the rover do the next day. And the way traditionally you do that is you have a whole bunch of flat panel displays and you look at flat images that are 2D projections of a 3D world, and then maybe you have some of them stitched together into panoramas, and you try to sort of mentally wrap that around in your head. And people who've been doing this for 20 years, and this is sort of the standard interface that they use, get reasonably pretty good at it. And one of the things they'll try to do, for example, is looking at a set of images, figure out, well, this rock that I can see in the image here and this rock that I see in the image over here, are they really the same size, and how far away are they from each other and from me? And they mentally construct a model based on just the 2D projections. As I said, people who've been doing this for 20 years get pretty good at it after a while, and it turns out it's actually a really, really tough problem. And we actually decided to go in and quantify how well they were able to do it. And what we found out is that people who've been doing it for 20 years, who are really, really good at it, actually suck at it, to be honest. That their understanding of the real world versus the mental model that they were reconstructing, and this is after years of practice, is massively error-prone. And that it is just an enormously difficult problem to do. And that's why we started to look at how can we use perhaps an immersive environment capability to reduce the errors associated with context understanding. And based on that need, we've developed a tool called OnSite. It runs on a Microsoft HoloLens, which is still out in the developer community now. It should be available for the consumer model in about a year or so. And we've developed this, working with Microsoft, developed this package called OnSite, which misuses the device, to be honest. The headset was designed as an augmented reality device. We actually use it as immersive VR. And what I've got is a very short video that sort of explains what OnSite is and how we use it, and I'll talk a little bit more about it when it's finished. About a 2-minute video. And there should be sound.
Hey, John.
Hey, Rob. Theme group meeting in 15 minutes. Why don't you get set up and I'll meet you on site in a few.
Sounds good. Hey, John.
Hey, Rob.
Come here and look at these rocks from this perspective. I think we should place an APXS here.
Oh, okay. Nice. I totally missed that when I was just looking at the images. Oh, wow. Look at this outcrop. You really don't get a feeling for the shape of it when you're just looking at your computer.
How about a mass cam right about there?
Agreed. We could really use the higher resolution there. Okay, I think we're ready for the meeting. Let's see what Jane and Samir think of this.
Hey, Rob.
Hey, guys.
Let's review our APXS target.
Those look like good targets.
We should get some good data here.
Then we wanted a mass cam of this outcrop.
Yeah, looks good to me.
Agreed. Let's move forward with this.
There's 3 really important things I want you to take away from that video in terms of explaining what OnSite is and why NASA has chosen to develop it and the value that we're getting out of it. First is the model itself and what people are able to do by immersing themselves in the environment. What they are seeing in the headset and in the application is not CG in the classic sense. It's not algorithmically developed, but it actually is real photography returned on a daily basis from the Curiosity rover that is used to create the environment itself. So it is an accurate depiction of the surface of Mars. When you put the headset on, you fire up OnSite, you are on Mars at the location where the rover is currently operating, and you are seeing what the rover sees. But more so, you also have the ability to, in effect, get off the point of the rover and the single viewpoint it has, and to walk around the environment and do exploration and look at things from different angles accurately with the correct coloration, the correct lighting intensity, the correct sizes, and everything else of all the features that are in the scene. That has enormous value in terms of understanding the context. I no longer have to worry about how do I interpret a photograph to understand if this rock over here is the same size as this rock over here, and where are they relative to each other in parallax. Instead, I can get up and I can walk over and I can look at the two of them, and that understanding becomes innate and instantaneous. We've done quantitative studies to look at sort of the before and after effect with the traditional systems versus the understanding that comes through using the immersive system. And there are significant factors of 3, 4, and 5 level improvements in the understanding and the accuracy that the science team gets of the scene. Second thing that's important is this is a whole new way to interact with and control physical devices. One of the things you saw in the video was the idea of walking over, designating a target, and asking for an instrument placement on that designated target. Traditionally, what the science team and the rover operators have done is use a whole bunch of command line-driven screens to generate text-level commands that are then uploaded to the rover eventually for execution. Now we're moving into a mode where my interaction with the physical device is to cross over in the virtual environment, designate what I want it to do by pointing to the target, telling the rover verbally, go here, do this, and the system has enough knowledge based on the geometry of the reality and this understanding of the virtual environment to translate all of that into the set of sequence commands that can then be uploaded to the physical device. So my ability to command the rover and how I do it shifts dramatically. I no longer care necessarily about the details of what joint of the rover arm has to move first or what wheel turn has to happen first to point me in the right direction. What I'm concerned about is what's the task that I want to complete. I need the rover here to do this instrument reading, and that's what I focus on. The third part is the collaboration aspect. Right now, I have 75 science team members who get on telephones and video conferences every single operational day to collaborate together to figure out what do we want the rover to do. There is a not insignificant amount of time that's spent in the discussion of saying, here's the rock that I want to study. Well, which rock do you want to study, this one or that one? I want to study the gray one. They're all gray. And you get into that sort of discussion pretty quickly. And so now I can, with my virtual team members standing there on the surface of Mars with me, I can walk over and say, this is what I want to take a look at. This is the area that is interesting to the science team. And they all instantly understand that. And the ability, no matter where I am on Earth, to collaborate with my team members in a remote location in real time has enormous value and enormous productivity improvements associated with it. There are other aspects of what we're doing, but that's sort of a quick nutshell of what OnSite is all about. The last thing I'll mention is that because we knew there would be a lot of interest in it, we actually have created a public version, which we removed the rover commanding part because we don't want everybody doing that. But there's a public version, and it's been sort of nicely packaged, and actually you have the opportunity to have Buzz Aldrin give you an 8-minute personalized tour of the surface of Mars that will be available about the middle of June. If you go down, for example, at Kennedy Space Center, it'll be one of the places it'll be showing. There's a lot more about it, but that's a sort of quick start.
Cool.
Thank you. Wow. And now for other ways to get to Mars, Julian Reyes.
These are all really awesome projects. So yeah, my name is Julian Reyes. I'm the lead producer on Mars 2030. This has been a project that's been going on for about 2 years, where we started a collaboration initially with MIT and their Aero-Astro Lab, and then it led to a conversation and a partnership with NASA to build this out. And the goal here is to create an experience that everybody can have and go to Mars and be an astronaut and go on missions that kind of unlock what Mars is and kind of look forward in what the possibilities are for a mission to Mars and what that could lead up to. So right now I'll just start off by playing if there could be some sound. Actually, I don't think they loaded the right presentation unless, yeah. Can someone press play there, or?
You should be able to.
Oh, okay.
The bottom button.
The button. Okay. So the whole, I mean, this whole project came together piece by piece, and we actually started bringing in people from the game development industry, folks from the game BioShock Infinite, and we started kind of putting all of them together, and talking to people out in LA who are doing a lot of multi-directional sound for VR. And it was really interesting, like I said, piece by piece. And through that construction of the team, we visited Johnson Space Center and Langley Research Center, and we tried to capture as much data as possible to integrate inside of the experience. Everything from the sounds of the rover that we got to drive out at JSC, which was pretty awesome. And to the spacesuits, the new Z2 suits that they hope astronauts will use. And, but going back a little bit, it all started with a conversation between myself, Sidney Doe, and Andrew Owens at MIT AeroAstro. And the question was, where are we today on a mission to Mars? And that kind of kicked off this whole project, and it's been really exciting ever since. So I already spoke about that. And again, like I said, this was about 2 years of going into and reading NASA research. One of the main documents that we based it all off of is the Mars Surface Reference Mission by Steve Hoffman. And we read through all of it. And I mean, the excitement every page that we turned, we're like, wow, this would be awesome for a VR experience. I mean, I can't explain how exciting it is. And peace, like I said again, and then we started looking at, okay, so what do habitats look like? And we worked with Pat Troutman at NASA as well, understanding what a habitat would look like, and getting data from the Evolvable Mars campaign, and kind of collecting all of that data and then integrating it inside the experience. And we're using Unreal Engine 4 to kind of put all of this in. So yeah, this is on a few pictures of our visit to Johnson Space Center and the Mars Yard, which was one of the coolest things ever. Like, you actually feel like you're on Mars. Yeah, and then this is, I think, the inside of the Orion capsule. And so what our main goal here was to kind of grab the latest in space exploration research and compile it all into one kind of piece. And then obviously real-time 3D rendering is pretty advanced because of how many different video games that they're out now, and over the past several decades, they've gotten really good at rendering in 3D. So we're using that as kind of the platform for our VR experience. And then we really wanted to apply the latest in multi-directional audio to really immerse someone. I personally think that it's 50% what you're seeing and the other 50% what you're hearing to be fully immersed in VR, and it's something really special when you have a good balance of both, and that's when you really start believing that you're on Mars or somewhere that you would want to be in VR. Oh, nice. So this is okay. Nice.
Good part of a video.
Let's see if I can load it up again. Okay, so here's the. Glad it worked. So, and one thing, if you guys hear the music there, we're actually going to record an original soundtrack with the London Symphony Orchestra to kind of play out while you're exploring Mars, which is something really exciting, really excited about. And yeah, that's pretty much it.
So where are we going to be able to go to experience
sorry
Mars?
about that. So we're releasing the experience in November, and it'll be out on Steam for the Oculus Rift and the HTC Vive. We are thinking of producing these smaller versions for the Google Cardboard and the Samsung Gear VR, but we really hope for the full experience to be on both the HTC and the Oculus.
So find a friend who's got a system.
Oh, and you could also play it in non-VR as well. So everybody gets a chance to go to Mars.
Okay. So for the actual astronauts who will go to Mars, there are some considerations that the people on Earth who get to jump into a VR Mars don't have to worry about. And Peggy Wu will be talking about that.
Thanks. So some of you might have seen this slide. The plan is that in the mid-2030s, we're going to be ready for manned missions to Mars. And just to step back a bit and give you a bit of context, station right now is actually pretty close by, 220 miles upwards. There's no comm delay. They've got the IP phone up there, so they could call down for pizza if they wanted. Delivery is a different problem. And the issue is, right now, the astronaut's not flying station. Mission Control flies it. To the moon, it's a bit farther. We've got a 1.2 second time delay one way, so it takes light 1.2 seconds to get there. To a near-Earth asteroid is a bit further again, 6.5 seconds. To Mars, at its closest, it's going to be 3 minutes, but at its furthest, we're going to be 24 minutes delayed one way, which means that if they have any issues, problems, if they call down, it's quite a long wait. That's more than 40 minutes backwards. That design reference mission is that right now we're going to spend 6 months going there, 18 months on the planet's surface until the planets align, and then another 6 months back. This means that the crew is going to be very different from the way that things work now. They're going to need a lot more crew autonomy. Here's a beautiful picture of astronaut Karen Nyberg looking out and doing some Earth gazing at that cupola. And most of the time, on the way to Mars, she's going to be looking at this. So the issues of sensory monotony and social monotony are things that we need to address. We've seen them in historical spaceflight, in analogs, in long-duration missions on Earth. And those challenges have been known to cause fatigue, anxiety, drops in productivity, basically make you a really bad roommate, and maybe even a worse crewmate. So NASA approached us and said, is VR a viable solution maybe to serve as countermeasures? And so we were looking at using virtual environments as a way to address the sensory monotony and social monotony. We did an extensive literature review, and we also conducted 2 astronaut training exercises at the HERA facility at JSC, soliciting feedback from some of the astronauts and what they might want to see in order to keep them socially connected to Earth and to fight the sensory monotony in the long-duration mission. And now we're carrying out a 12-month study at the High Seas facility, which you've heard a little bit about earlier, and I'll let the crew member give you a quick tour. So High Seas actually looks, parts of Hawaii actually looks a lot like Mars. Here's a picture. And so this is within the virtual environment Ansible, and we have a crew member who recorded a tour. There should be audio.
An avatar. This here is the main room, and that's where we work.
So this is our crew biologist.
Exercise and generally spend time together. And as you can see, it's very spacious. It's a bit like living in a hemispheric movie theater. You know, the kind where you can watch Omnimax movies. Let's enter the area where we eat and prepare food. At the kitchen counter in front of me, that is our coffee machine with a fridge underneath, our microwave here. And right where I am standing right now, in real life there is a table. That's where we have dinner together, because people tend to have lunch on their own or with someone else when they have time for it, but we make a point of having dinner all together. Climbing the stairs, you can see our blue yoga mats underneath. Okay, this to the left, right in front of me, that's a bathroom, and it's composting toilets to save water. And the other compartments are our bedrooms. Mine is right here, and in real life there is a small bed and a small desk. And that's a biology lab. So there we are doing some experiments with plants and with microorganisms. Right in front of me, that's our plant setup. You can see some plants growing in an analog of Martian soil. And on the top shelf, there is a hydroponic system. So basically you have some plants which have not germinated yet here, which will be growing in a hydroponic system, so just water containing some nutrients, no soil. And yes, we have a washing machine, even though we prefer to wash our clothes by hand when we are short on water. The last thing I want to show you is our solar panels. In the dome, we are powered with sunlight. So when we have a cloudy day, we often have to give up on some cooking or some experiments, which can be quite frustrating sometimes. Okay, that's all I wanted to show you. Thank you for following me. I hope you enjoyed the hub tour and have a good day.
So this project started 3 years ago. I think the Oculus Rift was still in a Kickstarter project at that point. So you can see the graphics have come a long way even in that short duration of time. But the point of the project is to really understand the psychological effects and the team dynamics of living in isolation for a long period of time. And so we're looking at, we've deployed the system at this 12-month study, and we're comparing the results from this study with an 8-month study of a different crew in the same facility. The crew members live in that habitat, which is about 1,000 square feet. In isolation, they've got the 20-minute time delay, so they don't have real-time internet. They can't just look up something. They actually have to email mission support, and someone will respond to their questions. When they come out, they have to wear their spacesuits, and so they never actually feel, the sunlight on their skin. Within the project, we did an extensive literature review to look at what are some strategies that promote psychological wellness, such as nature-inspired scenes, having different vacation spaces, having winter activities, and being able to make snow angels, for example. A couple of months ago, we had our first art exhibit with a local artist, Christine Schumacher from LA. And we have a club lounge where they could go in and watch movies together, watch different performances. And there's a big focus on connecting the family members. So we've allowed some of the family members' accounts so that they could always also log in, although not simultaneously. And this was a Thanksgiving event where we had different recorders for each individual, and they could record what they're thankful for. So when you play the different players, you see everyone sitting at the table together, and it looks like they're having Thanksgiving dinner together, even though they're 20 minutes in time away. We got some preliminary data results. This is just based on the first 6 months of the study, and they're very promising. We're showing that they're feeling closer to their family members compared to the control group. They're feeling more satisfied with their social relationships. There's potentially reduced stress in this group, and also a change in the perception of time. That's interesting because in some of our previous studies, some of the crew members said that the extended period of isolation made them feel bored, and that made them feel like time was slowing down. And so we were happy to see that at least we were going in the right direction in terms of perception of time. Some future work, of course, we have to finish completing the study. We're now at month 9 of 12. And we want to also be able to take the insights and lessons learned from this study to apply it to other populations of isolated individuals. Now, Mars astronauts, it's a great market, but it's not a very big market. We want to apply it to other populations, say individuals who are hospital-bound, who are isolated. And that's it. I want to thank my team at SIFT and also my collaborator, Jacki Morie and her company, as well as the Behavioral Health and Performance Group at NASA for sponsoring this work. Thanks.
Thanks, Peggy. So we do have some questions that have been tweeted, but I'm going to ask you one to begin with. Okay. And do you see haptics coming in, or do you eventually for the kind of training you're doing, or do you think it's always going to have to be the hybrid where you actually have physical objects?
I think there's pros and cons of having the physical objects, and then there's also pros and cons of having the haptics. Both have their place. I think being able to have haptics and then also still combine in with the physical objects could be very powerful. So haptics are coming forward. They're not the technology is not advancing at the rate that the virtual reality goggles are advancing. So I think that's the limiting factor.
And do you see having the ARGOS system and the mixed reality together?
Yes.
Yeah.
That's a primary goal for us to achieve this summer. The idea that you could have somebody, say in microgravity, doing an EVA on the outside of a space station truss while actually moving around in that gravity environment on a set of handrails with a mock-up is very powerful.
Thank you. And Dave, we had a question about why the HoloLens. Why wouldn't you use immersive VR? Why are you using a HoloLens? What are the advantages that you see there?
When we started with the on-site project, one of the things that we anticipated for how we wanted to use the device and how our team members would be using the device is that, as I said, these are 75 people who are distributed not just around the country, actually around the world. And we expected them to be using this from their home institution, literally in their office. And they wouldn't have a dedicated space, but they had to, we wanted them to have the capability to stand up and walk around the scene, but recognize the reality was that meant they'd probably be walking around their office. As one of the things that we are doing is we're sort of misusing the device. The HoloLens is actually intended first and foremost to be an augmented reality device where I can see the real world and then I have features that are placed on top of it. We're sort of misusing it by making it more immersive than it was originally intended to be. But in doing so, we were able to sort of take advantage of one particular aspect. When I have the headset on, what I see of Mars is not a completely wraparound thing, but instead I see a window. But around the very periphery, I can still see the real world. And very quickly, my hindbrain sort of accepts and ignores that. I focus on what I see of the virtual world in the window, but my hindbrain is keeping track of the fact that my desk is right here, and if I step that way, I'm going to bump into it. And so I can be immersive, but still have knowledge of the real world. And that was a very attractive feature for us for how we saw it was going to get used for this particular application. At the same time, we recognize there's a lot of advantages for a lot of other platforms out there. The intent is in the future that this is something that we will be porting over to other platforms. This is just where we started.
Okay, and what's the field of view of the HoloLens?
I couldn't tell you exactly what it is in terms of field of angle, but it's enough that, like I say, what you very quickly do is you mentally, consciously ignore the little peripheral vision aspect of the real world, but your back brain takes care of it for you. You're focused on what you see in there, and you're in the scene.
So it's almost like having a dimensional screen in front of you, but you still know that your desk is here and you
Right.
shouldn't trip over your office mate there. Okay, and Julian, I have a question for you. So in September, we get to jump into your virtual reality Mars and visit it. Are we going to get to see other astronauts up there, do you think? Are you going to plans for kind of a social experience on the red planet?
In November, you're with a crew of 3 other astronauts, and they're going on the missions with you. And we are pushing for a kind of joint experience. So, yes, to answer your question.
Okay, let's see. We had a question about what about the psychological difficulties of the transit times in space? Do you see something like Ansible being used throughout the entire thing or just on the surface of Mars?
Yeah, it would be great to even start during training. Astronauts have a long duration of training. A lot of that time, they're in a different time zone from their family members. And so they're already separated. So to get them kind of start at the training, through the transit, through the surface, and then even back, before they get back, we could start doing some of the reintegration and getting them more involved with, maybe the day-to-day lives of their family members, I think would be beneficial.
Cool. Dave, on those vocal commands where you ask the rover to do a task, how do you see that fitting in with the communication delay?
Well, part of it is, again, so I have to understand the context where I'm recreating the surface of Mars here on Earth in my office, in a conference room, whatever. When I'm creating the commands, I'm not commanding the rover real time on Mars. Right. I'm creating the command sequence that will be uploaded to the rover later. Just because the communication configuration that we have right now with the satellites at Mars that we use as communication relays, the reality is we get to talk to the rover twice a day for about a 10-minute block. And we basically get this burst of communication from the downlink of here's what the rover did yesterday, and we then review that information, and from that we create our command stream, which is then uploaded at the end of the Earth day for the rover to do tomorrow. How I create that command stream is what we're altering, and we're changing by allowing us, rather than having to type in commands, use voice commands and things like that.
Okay, and going on what Peggy said with the missions on Mars not being really controlled from the ground, do you foresee a time when the mission control is going to say, I want the rover to do this, but the people in the Mars colony are saying something else?
Well, okay, so one is important to understand that the application that we've got right now is being used for commanding Curiosity today, given the constraints of the realities that we have associated with our communications infrastructure and everything else, which obviously are going to be modified and expanded quite a bit in the future. But you do get into the question, not just for humans, but even as you embed more and more intelligence into robotic systems, and you are asking these systems, human or robotic or a combination of both, at a higher level of commanding, please go do this thing. They are getting an increased capability of saying, yeah, I hear what you say, but I actually want to go over here. And that's something we're going to have to contend with at a larger and larger sense. And the simple reality is, especially as we have human crews on the surface of Mars, we have to not only anticipate, but expect that the humans are going to want to have a fairly significant amount of autonomy. Here's the things we would like you to do. You go figure out how to make it happen will be probably a big part of the discourse we have back and forth.
Okay. I'm going to ask if anybody in the audience has a question. And who's got the microphone? Are there any questions out there? There's one right here in sort of fourth, fifth row back. Yep.
Where do you see the role of augmented reality in space exploration?
Wait, did you tweet that question too?
Yeah, I did.
Okay. Who wants to take that? Augmented reality, scroll in
I'll go and
space.
take that one. It's we see it in all phases. We see, today we're using virtual reality in crew training, We use it for hardware development. We use it for OpsCon development, procedure development. I think as we're talking about trying to use it for crew training, where you try to do training of the crew on the ISS for task, where they potentially had done the training maybe a year to 18 months prior before they have to execute a task, kind of a retraining with that. I think you're going to see it particularly used in that method to try and make the crews more efficient with minimal training time.
Yeah, actually, I want to augment that a little bit as well.
Augment the augmented question.
I had to think about that one. But we do have the very early stages of some operational augmented reality capabilities that are on space station right now. For example, we do have 2 headsets that were flown up. And one of the last things that Scott Kelly did when he was about to return from his mission was actually unpack and start to use them operationally, that are used specifically in the particular application, which is called Sidekick, that we have up there right now, specifically used to replace and displace hard copy manuals for various different procedures that are reasonably well understood, but can be very complex. Something like, for example, installing a hatch cover on an airlock hatch, which is a procedure that's done fairly frequently, but it's very long, very involved, multi-hundred steps sort of thing. And right now the crew normally would have a manual which they're trying to hold with one hand, where they hold themselves down to the floor with their feet and try to operate with one hand to do the entire task. But if you can displace the manual and have a headset on with augmented reality rather than full immersion, that can just sort of point and say, this is the lever you need to turn next, and step through the process, that's an incredible productivity improvement. We have, as I said, Sidekick is the very first steps of that sort of thing that are becoming more and more common. We're going to see a lot more of those in the future.
Thanks.
Sidekick is the name of the application, the augmented reality application specifically tailored towards procedure follow-through that is on board space station right now. It's an application developed by the Jet Propulsion Lab and Johnson Space Center.
All right, this is a question, I think, for Julian. What role do you see for the visual graphic performance artist in contributing to NASA's journey to Mars in the VR field? You see a way for creative people to get involved?
Of course. I mean, everyone on the team, I mean, we have environment artists, we have 3D modelers, all kind of contributing. And we have an open dialogue with the people at NASA to get the right information and translate it correctly into the engine. So, I mean, anybody, I mean, who does that and gets to have that conversation, I think it ends up being pretty fruitful in the output, especially when you combine someone that really understands, let's say, something like the habitat, and gets to speak to someone who really knows how to model something in Maya really well and integrate it inside of a game engine, then you have pretty great output.
And do you see maybe we can upload VR performances to the crew on Mars someday?
Of course. Oh, well, yeah, definitely. There's in the experience that there is a VR component within the VR.
VR within nested VRs. Okay. I have one question for Peggy, and then we'll take a couple more for the audience. I don't know. One more for Peggy, though. Peggy, in the system, the Ansible system, since the crew would be using that, are there any built-ins, or do you foresee a time when there'll be any built-ins to that system that can actually be diagnostic, that can maybe tell way in advance that there's some kind of psychological issue happening or starting to happen?
Yeah, I mean, we're not doing that now, but that's the great thing about VR or virtual environments and even augmented environments, right? Everything can be measured. And we have done projects with computer vision looking at heart rate variability, some of the basic research work of does their behavior reflect their real life in the virtual world? Some of those still have to be addressed, but I think, yes, I think that would be a great application.
To the future. I think we are finished. Thank you all for sitting on this panel.